So in the last videos, we have seen dynamic programming and even that graph data structure as a separate document I will upload in our running notes. So next concept is priority queues. Priority queues, or we can say heap. So what is mean by this priority queue, or what is mean by these heaps? It is something like a tree. Okay, it is nothing but it is nothing but a tree, nothing but a tree. So that tree is called as heap tree. So what is mean by heap tree? So heap tree is having one property where, where minimum or maximum element so will be there, okay, as a root node, so every time minimum element or maximum element will be there in the root node. For your understanding purpose, just I am giving one tree. Assume it is a tree where, so I have node 1 is there, and here we have 7, and here we have 3. So next we have 17. Okay, next we have 9, and here we have 10. So here we have 15. Like this, it can be anything. So first minimum element will be there in the root node. Minimum element will be there in the root node. So this element is nothing but, so first we are going to access this element only. Okay, sir, this element is accessed. That means deleted from the queue. Then automatically what will happen? So we have to write an algorithm such that, so next element should become, okay, next element should become the next minimum element should come to the root. Like this we have to take. Okay, next element, next ready to access element should become root node. Okay, and there are two properties. What is the first property I covered? So root node should contain minimum element or maximum element. So after accessing, if it is not satisfying the properties, we have to do heapify concept. Heapify will be there. Heapify means what? We have to rearrange the tree in such a way that the minimum element or the maximum element should come to the root. Like that we have to rearrange the tree. This technique is called as heapify. So I'm not going in detail, just at a top level I am trying to explain. So inside priority queue, that is inside heap tree, the topmost element will become ready to access. It is nothing but either minimum element or maximum element. Then what will happen? Remaining elements will be there in the tree. So next time which element you have to access, the next element which is ready to access is nothing but either next minimum or next maximum. You have to bring that element from your tree to root node. Now this element is ready to access. At the same time, while doing this, we have to satisfy one more thing. It should be a complete binary tree. Complete binary tree means what? So first, if you are starting from here, next you have to fill these two children. Then we have to fill this child, like this, top to bottom. Okay, top to bottom, and left to right. Like this we have to fill. That's why even we have 17 and 9 is there. After removing 1, 3 came here and 9 came here. I'm keeping 17. Don't bring 17. If you bring 17, 9 will be there here, or some other element will be there here, and this element will become empty. So in the third level, first element, second element, third element, if any empty is there, that we have to provide here. Okay, like that we have to implement the program. Sir, compulsory we have to implement this by using either array or list. The problem with this tree data structure is nothing but, so whenever we are identifying the minimum or maximum element, we can't bring that element to the beginning. That is nothing but the problem what we are facing with the tree data structure. That's why here we are going to use list concept. So where we will store all the elements, and the minimum element will be always the access first. So I think the concept of this priority queue at the top level, is it clear for you? Please confirm.
Yes, sir.
Yes, sir.
Right. See, this is nothing but in everywhere we are going to use this. Like if you take traffic signals, So here how it is going to process. So the vehicle which is having highest priority will be given the access first. Ambulance, next politician vehicles, police vehicles, next people, like that they are going to give. Even in the hospitals, so doctor is going to take high priority cases first. So in such a cases, this priority queue will come into the picture. Okay. So in our implementation, we are taking either maximum priority or minimum priority. Like this we have. One second. Yeah. So this is nothing but what we have. So I told applications, right? So where we are going to use the priority queues. So in the hospitals, okay, visiting the doctor is based on the priority. Next and after that, we are going to take. So next and after that, we are going to see the traffic signals. There also we are going to use priority queue. So if we want to, we can implement our own priority queue also. So, but I don't want to take implementation in detail. So just I will use some priority queue which is already available. So in our Python, we have priority queues is already implemented. So for that, there is one module is there with name queue. So from queue, import priority queue. So we have already priority queue is there. Just I am going to import that. Now I am taking queue is equal to, I am creating new object for priority queue. Listen carefully. There is one special method is there called put, which is going to insert that element into the queue. Similarly, I am going to take the next element called 2, next element called 5. So next element is called 1, next element is nothing but 3. Like that it is going to store. Sir, which element it is going to take first highest priority? Now you can able to see that element we are going to access. So while not of queue dot empty, until your queue become empty, okay, until your queue will become empty, just we are going to print that item. So queue dot get, this get method is going to remove the minimum element or maximum element from the queue, and it will return. Now have a look once what output we are going to get for this program. So py space I am taking test dot py. You can see the minimum element is giving first priority. next 2, next 3, like that it is taking. So this is nothing but just one simple example. If you want to see the internal structure of that priority queue, let us see what will happen. Internal structure of a priority queue, I am trying to explain. Have a look once. See, after this, just I want to print that queue, sir. See what will happen. So we have object is there, you can convert that into list so that we will get in the form of list. No, it is not iterable, so we can't able to convert. No problem, you can't able to view that. No issues, you can leave as it is. This is nothing but how to get the objects one by one from the priority queue. You can see in which order we inserted, that is not at all a matter, but it is always considering the minimum element which is having highest priority. Sir, is it possible to do this with collections like list or tuple, something like that? Yes, you can do that. So here you can see I am taking 4 comma, okay, 4 comma. Just I am giving some content like read. This is nothing but something like a tuple, right? Next, similarly, so 2 comma, I am going to give something like a play. So next term, I'm taking 5 comma. So write something like this, just meaning some priorities and its meaning I'm giving. So we have 1 comma. Here I'm going to give code something like this I have given. And here also, so 3 comma I'm going to give study. Like this I have given some elements. Now I want to access this based on priority queue. Now you can see the first priority will be given for code. Second priority will be given for play. Then third priority will be given for study. Next read, next write. See, based on this first element. So maybe it is considered as a rank. So which is going to get the highest priority? This one. Like that we can implement priority queues. So even I told somewhere in the last sessions how to identify shortest path for a graph. If you take any graph, for example, if you take the same example, 0 to 5, okay. So next 0 to 1 is there and 1 to some other node and like this. And 2 some other node, maybe 4 and then connected. Like this we have. Suppose consider this graph is having some limits. So like 2 and this one is 1, this one is 3. So next one, this one is a 7, this one is 9, this one is 2, like this. So there is a weight for each and every edge. So now what is your task? You have to identify the shortest path. How you can able to identify shortest path? For that compulsory you have to go for priority queue. Why? Because see, if you take 0, from 0 we need to identify the adjacent nodes. We have 3 adjacent nodes are there. Sir, from this we are going to select the minimum element or not? Yes, the node which is having or the edge which is having minimum cost we have to select. So in this, can I say this particular value will be considered as a weight or not? Yes. So the edge which is having minimum weight, it is going to consider. Suppose starting from 0, if you take, so first edge is nothing but what? 0 to 1. Okay, 0 to 1. So its weight is nothing but 2. And the next edge is nothing but 0 to 5. Its weight is nothing but 1. So next 0 to 2. Its weight is nothing but 3. Like this, if you have, the first parameter is weight and second parameter is nothing but node. So if you process this, which one you will come first, sir? 1 comma 5, right? That means this is nothing but I can say shortest path. Okay, like this, from one node to another node, how you can identify the shortest path? By picking that, by adding each and every element into the priority queue. Anyway, our priority will give always shortest path first. So I think technically how we are working, is it clear for you people up to this, whatever I covered? Please confirm.
Yes, sir.
Right. So we can implement our own. For that, we have to use a heap data structure. So I am not going in detail into this. Just with this, I am going to stop a priority queue. So of course, still so much content is there. So maybe if time permits, I need to prepare more on these heaps. Once if I prepare, I will share that videos. So outline how this priority queue is working. Is it clear for you people, everyone?
Yes, sir.
Yes, sir.
Right. So next, with this, I'm going to stop a priority queue. Later, I will provide if any stuff is there related to that. So now, I need to talk about the next one, which is nothing but greedy algorithms. For this also, just I will give at a top level. Let us see what is a greedy algorithm, how you can work with greedy algorithms. See, I think you have heard about this terminology in regular usage also. See, when you are playing any games, okay, or when you are searching for any data, or even in the real time also, always we will try to use greedy. Greedy means what? So, which is going to maximize or which is going to minimize our solution. Okay, when you have a real time problem, you will always search for the maximum profit or minimum profit or maximum value, minimum value. Like that only we will implement. So best example, see the main purpose of this method is to find the optimal solution. Okay, the main purpose, the main purpose of greedy algorithms. Okay, greedy algorithms are to find a optimal solution. Optimal solution. So let us take one best example for use. Okay, see I have some coins. This is also a problem in greedy, sir. Coins, exchanging the coins or money denominations like this we have. Suppose consider I have a shop there. So one person purchased some item. I need to return 52 rupees to that person. Okay, he has given some 100 rupees. So the cost of the product is nothing but around 48 rupees. So he has given 100 rupees note. If you minus 48, we got 52. So we have to return this 52 rupees to that person. Can you please tell me how you are going to return this 52? Can you please tell me what denominations you are going to prefer for this? Please confirm. Yes.
150 to once.
Yes, that's all. 150 rupees note and 2 1 rupee. Okay. Right? Sorry, 1 2 rupees coin. See, there are so many possibilities will be there, right? There are so many possibilities will be there. So consider, so we have coins are there. We have coins are there. The coins which are available with me is 10 rupees coin, 5 rupees coin, so 2 rupees coin, 1 rupee coin, and 50 rupees. Like this, we have 50 rupees note or coin. Something like this we have. See how many possible solutions you are going to get, maximum possible solutions you are going to get. For example, consider the first case, first solution is nothing but, so I will select 150 rupees note. So plus I am going to select, okay, so 2 rupees coin 1. So that what will happen? 50 plus 2 will become 52. We have another option. Second solution is also there. What is that solution? I can select 5 10 rupees notes. Okay, and 2 1 rupee coin I can select. So that what will happen? 50 plus 2 we are going to get 52. But which is the best? In this case, how many denominations you are using? Only two. You can see 1 5 rupees, 2 rupees and 1 5 rupee note. Two coins we are going to use. Okay, but in this case, how many coins we are going to use? How many notes you have to select? Sir, maybe 6 coins I have to use. So if you take third case, so maybe I can use so 5 into 10, 5 into 10 plus 2 into 1 like this. Okay, so in this case what will happen? So 50 plus we are going to get a 2, so total 52 we are going to get. So where how many coins will be there? 11 coins will be there. So like this we can find n number of solutions. Okay, so like this we have, so 2 6 2 6 11. Okay, sir, among these even we have multiple options. In this, which one we are going to select? Second, right? Because with a less denomination we can able to get more profit. This is nothing but the convenient way. Finding this kind of optimal solution is nothing but the agenda of greedy algorithm. Can you please confirm, is the outline of these greedy algorithms are clear for you people?
Yes, sir.
Yes, sir.
Right. See, what is the algorithm that greedy is going to follow? How you can find out optimal solution? Please have a look once. In this case, initially we will consider result is equal to empty or 0. Then while all items, okay, we will fetch all items are, okay, all items are considered So while I can say items, one by one items we are going to select. See, after selecting items, what we are going to do is we will select an item. We will select an item. Which item we have to select? Which should give either maximum profit or minimum profit, right? So maximum value or minimum. So in some cases we need maximum. In some cases we need minimum. If you take this coins problem, we are always searching for the minimum number of notes that we are going to select, right? There we are going to give an option called minimum value. Suppose you are playing a game. So in that game, I want to earn maximum profit. In such cases, what we are going to do? We will identify the path which is going to give the maximum profit. Like that, we are going to take. So we are going to select an item, and if that item is feasible, okay, if that item is feasible, okay, if the item is feasible, so if the item is feasible, then add that item to result, add that item to result. At last, what we have to do, sir? We need to return result. We need to return result. Beyond that, nothing. So we are going to take all the inputs and we will select one item. Is it giving feasible solution or not? We are going to check. If it is giving feasible solution, we will add that into the result. Beyond that, nothing. Is the algorithm in this, is it clear for you people? How the algorithm we are going to use for greedy? Is it clear?
Yes, sir.
Right. So next we are going to see one problem related to this. So how you can able to implement this one. Okay, minimum coins related problem I'm going to explain. Just to have a look once. See, consider we have coins are there with me. The coins are nothing but something like 5 rupee coins we have. So 10 rupee coins we have, 2 rupee coins we have, and 1 rupee coins we have. And the amount which I have to return is nothing but same example I am taking 52. So then we have to find out the result. So maybe I'm creating a function which is going to take these coins and then amount, and it has to return the minimum number of coins that you need to select. So def, I'm going to define the function. So which is going to take coins and then amount. Let us see what we are going to do. Is coins is a list or not? So initially I'm going to consider my result is equal to 0. Better to sort these coins. Okay. So coins dot sort. So that what will happen? We are going to get the minimum coin first, maximum coin next. So can I sort it in reverse order? Yes, because maximum coin we are going to get first, so that we can find out all feasible solutions. Okay, maximum profit. Now, what I'm going to do is for each coin in coins, I'm going to select one by one coin. See, assume I have these coins are there, right? Once if you sort in descending order, yeah, right. See, here we have coins like of 10, 5, and then 2, 1. I sorted these coins in descending order. Okay, I sorted the coins in descending order. So what we are doing in this is, I will select the first coin. What is the first coin that we have? 10. Is it less than the amount what you are giving? That I am going to check. So first coin is a 10. Is it less than or equal to this amount? Yes, right. Then what we are going to do? If the value of a coin is less than or equal to the amount whatever you have, then I'm going to take that value. For example, x is equal to amount by that coin. Amount by that coin. Better to take double slash. Now see what will happen. X is equal to, what is the amount? 52. 52 by 10. So what we are going to get? 5. So we have to select 5 10 rupee coins. 5 10 rupee coins we have to select. That is my agenda, right? So then what we are going to do is, we are going to add that value into the result. Result is equal to already available result plus x. So initially how many coins we are going to select? Result is 0. We added these 5 coins. We have to select 5 coins. So then next step is what? We have to reduce that number of values from the amount or not. Amount is equal to amount minus, so how many coins you have selected into what is that a coin value, sir? That also we have to take, right? Like this I am taking. Now see what will happen. The total amount is 52. From that we are going to reduce x into coin. X value is 5. The coin which we selected is a 10. So total 50 we have to reduce, so that we will get 2 coins. Since it is a loop, it will take one more coin. What is another coin that we have? 5. So is that a 5 coin is less than or equal to amount? No, condition not satisfied. Take the another coin 2. Is it less than or equal to amount? Yes. Then what we are doing? X is equal to, what is the amount that we have? 2. So 2 by 2 I am taking, where it is going to return 1. We have to select that one coin. That one I am adding to the result. So total 6 coins. Amount is equal to, what is the amount available? 2 minus x value is what? 1, and the coin which you have selected is 2. So 2 minus 2 will become 0. So amount will become 0, right? So I will keep on doing this process. Whenever if the value of amount is equal to 0, simply I will break the process. That's all, sir. Automatically you are going to get, so how much amount we have to take. Now observe carefully. I'm going to run the program. Since the value of amount I have given is 52, so we are getting none, because we have to return the result at last. Now you can see total how many coins are required? 6 coins. Sir, I'm going to increase, so I'm going to take 150 rupees coin also. Now how many coins that you are going to get? Only 2 rupees, 2 coins. So 2 coins is sufficient, right? Yes, because 150 rupees coin and then 1 2 rupees coin is sufficient. Assume 2 rupees coin is not there, then what will happen? So how many possible combinations we are going to get? 3. 150 rupees coin and then what? 150 rupees a coin. So then one 3 1 rupee coins. 50 plus 3. Sorry, 1 plus 3 coins we have to select, right? Now have a look once. It is giving some wrong answer. So 50 rupees coin 1 and 1 rupee coins 2. So 1 plus 2, 3. Correct only. 3 coins we are going to get. Okay. Like this we have. I think you understood how we have implemented this algorithm. Are you clear with this? How you can find out optimal solution for this? Please confirm.
Yes, sir.
Yes, sir.
Like this, there are n number of real-time problems are there. We can solve all those real-time problems by using this. There is no external technique, sir. Just we have to imagine the problem statement and check whether you are expecting the maximum profit or minimum value or maximum value. Based on that, we have to write. Are you clear with this?
Yes, sir.
Yes, sir.
Right. So with this, I'm going to stop. Almost every concept I covered. And in the graph data structure, I left 2 concepts, sir. So for that, I will prepare the videos and I will share it. Okay. So only 2 topics are there, like shortest path and then minimum cost spanning tree. For these, a proper solution. Of course, lengthy solution we are getting. So I'm trying to show within 1 week, I will share 2 videos. So one is for shortest path, another one is for minimum cost. I will share the video support for this. So with this, almost all the topics we finished. Maybe if one or two is missing or more problems are there means I will share that. With this, I am going to wind up. Is it clear, sir, up to this?
Yes, sir.